Hello, Honors Chemistry, and welcome to 7.8, Acid-Base Reactions and Gas Evolution Reactions. I think the way this is going to split is this first one will cover acid-base and the second one will cover gas evolution. But let's talk about why they're grouped together, right? So going back to one of the questions in your outline, why are they grouped together? What do they have in common such that we would dump them together? And if we think about it, right, they are both aqueous reactions, right? So were the precipitation ones, but aqueous, right? In that one or both of the reactants are going to be aqueous in nature, right? Meaning it's the chemical dissolved in water, right? So water will be the background for these processes, right? In addition, right, these are all essentially the same type of reaction, right? In that, when we talked about precipitation, right, we said once we identified that there were two ionic compounds, it was as simple as doing what to figure out the products? Right, switching the cations, and it's the same thing here, right? So really, these are just an extension of what we've already talked about. Just now, instead of seeing a precipitate, right, instead of visualizing the solid formation, right, now for an acid-base reaction, sometimes there's not a lot to see, actually, right? pH is the thing we would monitor to know something happened, right? And then gas evolutions, obviously, there will be bubbles, and that's pretty clear. All right, so talking about neutralization reactions, this is the one from your guys' book, wherein we have an acid, right? And going back to chapter 5, acids are the things that have hydrogens out front, for our purposes anyway, right? Bases are often going to be metal hydroxides, okay? Metal hydroxides, again, for our purposes. And what's going to happen is the same thing we talked about before. All we're going to do is switch the cations, right? If we think about HCl, right? H is the cation, right? NaOH, sodium is the cation. We would switch those, which means that Na is now stuck to Cl, and the H and the OH are stuck to each other, right, is what that means. And anytime we're tempted to write H and OH together, we should think to ourselves for 2 seconds and be like, oh, yep, that's water. And then you'll always write water on your papers, and you will not give me HOH because, you know, you guys know better. All right. This is the table from your guys' book, which lists some of the common acids and bases. But again, right, for bases, all we're doing is we're talking about metal hydroxides, right? And for our acids, right, these are all things that we learned back in chapter 5, right? Where basically we can have a binary acid, right, which would be hydrogen plus some other element, or we can have an oxy acid, which would be hydrogen attached to pretty much any of the polyatomic ions that we've talked about to date. All right, so let's go ahead and do a practice together, right? So it says that we have some sulfuric acid and some KOH, right? So let's go ahead and do this. So we would like to do the molecular and net ionics, so let's start by writing down our reactants. So we have H2SO4, and it's aqueous, and we've got some KOH, aqueous, and so we would look at this and say, oh, we have an acid, we have a base. All we're going to do is switch our cations. Yes? So I'm going to form water, and my other thing is going to be potassium. Will now be stuck to that sulfate, right? And potassium has a charge of +1, sulfate has a charge of -2, which means it needs to be K2SO4. Now we'll apply our solubility rules, right? Potassium is a group 1, which means always soluble. And because we have aqueous reactants, there is water present, so K2SO4 will be aqueous, right? So that's our complete molecular. Now if we want to whittle this down to a net ionic, right? We'll just do all the steps, right? In order to do a complete ionic, we will dissociate the things that are, right, they must be ionic and aqueous, right? So that's what we're going to look for. And again, acids are going to get treated like they're ionic, right? So we have 2 H plus aqueous, and we have 1 sulfate aqueous. We also have a potassium aqueous. Oh, we didn't balance this, did we? Let's balance. That should be balanced. All right, we have 2 of those, and we have 2 of these. Oh, and we have, again, this is not ionic, nor is it aqueous, so we're going to write that down the way it's shown, right? And this one is ionic and aqueous, so 2K plus aqueous plus a sulfate aqueous. All right, now we'll go through and we'll cross out the things that are exactly the same on both sides, which includes sulfate, potassium, and everything else becomes our net ionic, right? So 2H plus aqueous plus 2 hydroxide aqueous gives us our 2H2O liquid, right? And then if we wanted to, as a last step, we could reduce this down. And then we will have answered the question. Yes? All right. Now, thank you for listening. Be good and stay tuned in the next one where we do the back half of 7.8 and we talk about the gas evolution reactions. Same principle. We just what we have to be on the lookout for changes a little bit. All right. Thanks for listening. Be good and I'll see you soon. Bye.